All right, here we go. So we are starting our fourth day of review. This is our third topic. This far we've done factoring, the X method and grouping. We've done multiplication and division. And this is our third topic, which is nth roots. So this is when we were first learning about square roots. We learned about the index, the little tiny baby number on the shelf. We learned about the radicand, which was the big number on the inside of the radical. And then we also can sometimes have an exponent with the radicand. Now, the big thing here, remember, was we were learning that radicals can sometimes have one solution and they sometimes have two. So we learned way back when, that if the radicand, the big number underneath the radical, if you look at your index, the little number on the shelf, if it's even, that means you're going to have two answers. Remember, a positive and a negative. If the index, the little n on the shelf, if that is odd, you will only have one answer. So that's the big idea here. So we are going to learn and review how to rewrite these and put them in our calculator and solve some little baby equations with them. So let's start off with our two multiple choice questions. They ask us to rewrite the radical. Okay, this is a lot like logarithms and exponentials and going between the forms. So the first thing we're going to make sure we write down on our page is how to rewrite it from one form to the next. Okay, so this is an exponential form. It is a, that's our negative 243, to the power of b over n. That's exponential form. We want to write it as a radical. We want to write it as a radical. Okay? Our radical has the a on the inside. Our b, the number on top, is our exponent. And n is the index, that number on the shelf. So we need to be able to turn this problem into a radical. And it's just rearranging. I would definitely add this to your notes. A little star by it. Okay, so if we look at this problem, what is my a value up here? Negative 243, and I'm just going to write that off to the side. Negative 243 is my a. What's my b? 1. And my n? Perfect. Okay, now all we need to do is take this and rewrite it as a radical. So we're going to have a radical. My a value, which was negative 243, is on that inside. My b is my exponent. And my n is the little index, the number on the shelf. And that's it. We rewrote it. So here, if I was looking for my answer, I would select A. That is how we rewrite it. What would have happened if this 1/5 would have been negative 1/5? Yeah, if there is ever a negative exponent, you do everything exactly the same, except you do 1 over that root, okay? So if you ever run into one where the exponent is negative, just leave it alone. Just remember your final answer will be 1 over, okay? So that is rewriting it. Next, we are going to rewrite it, and then we are going to figure out what the roots are. So same thing, but we're adding a little step on. So we're given 25 to the power of 3/2. We need to find the roots. Okay, so our calculators are going to do a lot of our job for us, but the first thing we need to do is just rewrite this, just like we did before. So we have an A, a B, and an N. Our A is 25. our b,
3.
and our n.
2.
Now we're ready to rewrite it. So we draw our square root.
25 in the middle.
25 on the inside.
30 is on the shelf. We wrote 24.
Oh, I'm crazy. 25 on the inside.
2 is the end, and then the inside 5 and 25 is the
2 is my index. 3 is my exponent, so it goes on the inside. So that's it all rewritten. The square root of 25 to the power of 3. Now it's important for us to rewrite this first because that index, the end value, tells us something. What does this 2 tell us? It's even, so it'll have 2 solutions. So the reason we're rewriting, this tells us this is even. So there are going to be 2 roots. Okay, to find those 2 roots, we need to plug this into our calculator. Okay, if you don't remember, grab a calculator in your hand, turn it on, clear out any nonsense in it. You always want to plug in your index first, your little baby number in the shelf, so everyone should click 2. Then if you click math, you'll see option number 5 says x root. If you go down to that and click enter, you'll see it turns it into a second root. After you have that second root, you can type in 25 caret or to the power of 3 and click enter. So you type in your index 2, go to math, down to x square root, which is option number 5, and then type in your 25 caret 3. Now when you type it in, the only answer that shows up is 125. But is that the only answer? No. Like Rachel said,
It's D.
it's 125 and it'll be the negative too. Negative 125 also. So our answer is D. Okay, one more time for the calculator. You type in the index, which in this case our n is 2. So you type in 2. You click math. Math. Then the 5th option is it has a little x and a square root. Go down to option number 5 and click enter. And now you should have a second root in your calculator and you can type in 25 to the power of 3. Then when you click enter, you'll be good to go. It'll give you 125, but we know that also negative 125 is an answer because it had an even index. That is how we rewrite and use our calculator to evaluate. Okie dokie. Don't change it. That is the first little bit of info you need to know for your final. You good now? Okay. The second thing you need to know for nth roots is we need to be able to solve some equations. Okay, now these will be solved just like you've solved every Algebra 1 equation you've done. Now, there's only one little catch, which what's interesting is if I ask the class what's the opposite of adding, you would probably say subtracting. And the opposite of multiplying is division. What's not super obvious is what's the opposite of an exponent?
A root.
A root. Yes, exactly. So this problem will still use our opposite of adding, opposite of multiplying, but we're also going to need to be able to use roots to undo exponents. In the first and second problem, you can see I have an exponent of 6 and I have an exponent of 2, don't I? The only way we're going to be able to get rid of those and solve for x is using roots. But we're going to start off solving it like we We always solve problems, and that's with waterfall down the equal side. I also usually highlight wherever my exponent is or draw a box around it, because my first goal is I need to get that exponent of 6 kind of by itself, because I need to be able to get rid of that because that x is stuck in there. So what should I move? How do I move a negative 15? Plus 15 on both sides. That makes it cross out on the left. And now I have my exponent by itself over there. X plus 1 to the 6th on the left. And 64 on the right side. Yep. Okay. Now we can see how x plus 1 to the power of 6, that's my exponent. It's all by itself now, which is good. Now I can't subtract that 1. I can't move the x until that exponent of 6 is gone. So, like we discussed, the opposite of a power is a root. So what root will help me get rid of a power of 6? What type of root? Can't just be a normal root. What number goes on my shelf?
2.
Not a 2.
6.
6. In order to get rid of a 6 power, we need a 6th root. So we're going to take a 6th root on both sides. Because again, the opposite of a power is a root. Okay, but a square root doesn't get rid of all powers. A square root would only get rid of a squared. A third root only gets rid of a third power. Here we had a 6th power. We needed a 6th root to get rid of it. So on the left, that 6th root and my 6th power cancel each other out. On the right side, I got to figure out what the 6th root of 64 is. That's where I type in my 6 in my calculator. Go to math. Go up down to that x root, option number 5. And you should see your calculator turn into a 6th root. Type in your 64. And like Sakai said, should get 2. One last thing to do. Subtract the 1. And then circle our answer. On the left side, 1's cancel. X equals 1. Done. So it's very similar to Algebra 1 that you've been doing. Only the difference is we're going to need to use a square root or a third root or some type of root. Second one, draw your waterfall down. Equals. I like to box or highlight or use a colored pencil to note where my exponent is. Here I have x minus 5 to the power of 2. So there's 2 things we got to get rid of, aren't there?
7 and 6.
7 and 10. Which one should we move first?
I thought you said it's 7 and 2.
7 and 10. The 7 and the 10. Because we need this to be by itself before we can use a root on both sides. Just like over here, we needed this by itself first, so we added 15.
So it's minus 10.
That's minus 10 on both sides.
And the first one crossed out. Cancel out.
Yep. Subtract 10 on both sides, 10s are gone on the left side. Okay, now we still need to get rid of the 7. And now, in my experience, a lot of students like to try to subtract that 7. Why can't you subtract it?
Oh,
What would we do though?
divide.
We would divide it. Because what's happening between the 7 and that x minus 5? They're touching, so they're being multiplied. So the opposite of this multiplication that's going on is division. So we divide both of these sides by 7. 7 divided by 7 is 1, so they're gone. On the right side, 243 divided by 7, 49. Now that exponent is by itself, we have x minus 5 to the power of 2. So the only way we're going to be able to move the 5 or the x is to get rid of that exponent. So what type of root gets rid of a second power? Yep, a second root. Sometimes we call it a square root. Fancy name for it, but it's just a second root. Again, why do we choose a second root? Because it matches the power. So these second root and the second power cancel. We're left with x minus 5 equals square root of 49? 7. One step away. We just need to add the 5. X equals 12, I heard. Yep. That is your answer. And you are done. That is the last top, or the